Good afternoon, friends. Now we'll have some more problems on queuing theory. So the problem statement goes like this. So the people arrive at a cinema ticket booth in a Poisson distributed arrival rate of 25 per hour. That means in 1 hour, 25 customers will join the queue. The service rate is exponentially distributed with an average time of 2 minutes per customer. So that is for serving one customer, so the time taken is 2 minutes. So both should be hours or both should be in minutes. So calculate the mean number in the waiting line. Mean here means average number of customers in the waiting line, the average waiting time of individual customer, the average number of customers in the system, that is both who are in the waiting line and at the ticket counter, the average time they are spending in the system, that is how much time a customer waits in the queue and how much time he spends in the ticket counter. So that is the average time individual customer spends in the system and the utilization factor. Now, so that is the arrival rate. So that is lambda is 25 per hour. So that is in 1 hour 25 customers will join the queue. The service rate is 2 minutes per customer. So that is 30 customers per hour. So it is 2 minutes per customer. So that is in 2 minutes one customer is serviced. So that is totally 30 customers will be serviced in 1 hour. So length of the queue is given as lambda square divided by mu into mu minus lambda. So substituting lambda and mu, so we are getting 4.17 persons. So at a time, if you see the number of customers in the queue at a particular time is 4.17. So round it off, 4 customers in the queue. So expected waiting time in the queue. So that is given as uh, lambda divided by mu into mu minus lambda. So we are getting this as 1 by 6 hours. So converting this hour into minutes. So that is 1 by 6 into 60. So that is 10 minutes. So totally a customer wait for 10 minutes in the queue. Then expected time in the system, so that is given as 1 divided by mu minus lambda, so that we are getting as 1 by 5 hours. So that is hour is 60 minutes, so 1 by 5 into 60, so we are getting 12 minutes. So that is he is waiting in the queue here for 10 minutes, and 2 minutes will be spent in the ticket counter. So waiting time in the queue is 10 minutes. So waiting time in the ticket counter is 2 minutes as per the statement of the problem here. So totally he spends so that is 12 minutes. So in the system, waiting time 10 minutes and waiting time in the service counter, that is ticket counter, 2 minutes. So total it is 12 minutes. So utilization factor, so that is lambda by mu. So that is the formula. It is 83.34% is the utilization factor. Then one more problem, a TV repairman finds that the time spent on his job has an exponential distribution with the mean 30 minutes. If he repairs in order in which they come in, and if the arrival of set is approximately Poisson with an average rate of 10 per 8 hours a day. So that is the customers who are coming is 10 customers per 8 hours a day. What is the repairman's expected idle time each day? How many jobs are ahead of the average set just brought in? So that is the question. So from the data of the problem we have, so there are, okay, so that is 10 customers in 8. So the if the TV shop is open 8 hours a day, so that is uh, so the number of TV sets comes, so in the entire day is 10. So if you calculate per hour, so it is 10 systems, that is 10 TV units in 8 hours. So in one single hour it is 10 by 8, so that is 5 by 4 sets per hour. And the service rate, so it is said that, so it is okay, so that is 30 minutes. So that is a TV set is worked on for 30 minutes. So that is okay. The time spent by the shop repairman on one single TV set is 30 minutes. So in 1 hour he is repairing two sets. So it is two sets per hour. So the expected idle time of the repairman each day. So how much time the repairman sit idly. So it is the number of hours for which the repairman remains busy in an 8 hours day. So it is the utilization factor, that is lambda by mu into number of hours. The utilization factor is now, so that is 5 by 8. So we are getting lambda here as so it is 5 by 4, so and divided by mu, so that is 2 sets per hour. So 5 by 4 divided by 2, it becomes 5 by 8, so that is the utilization factor. So that much time, so he is getting utilized. So in 8 hours, so he is busy for 5 hours a day. So hence the idle time for a repairman in 8 hours a day will be, so he is engaged in his work for 5 hours. So the remaining 8 minus 5, so that is 3 hours he will be kept idle. So expected number of TV sets in the system, those who are in the, which are in the queue as well as in the service table. So that is given by lambda divided by mu minus lambda. So substituting everything, we are getting so two TV sets in the system. So thank you.